Hey there, science fans! Welcome back to another thrilling episode where we unravel the mysteries of the universe. Today we're diving into the exciting world of kinetic energy. It's one of the fundamental concepts in physics that helps us understand how things move and interact. Now, kinetic energy is just a fancy way of saying energy of motion. Whenever an object is moving, it possesses kinetic energy. Anything that moves has kinetic energy. It's all around us. From the cars on the street to the kids playing in the park, kinetic energy is in action everywhere. The faster something moves, the more kinetic energy it has. So, a speeding car or a high-speed train has a lot of kinetic energy compared to something moving slowly. The heavier something is, the more kinetic energy it has too. This is why a massive freight train has more kinetic energy than a bicycle moving at the same speed. It's like when you're running, the faster you sprint, the more energy you feel you're using, right? That's because your kinetic energy increases with your speed. Scientists have a neat formula to calculate kinetic energy. Ke equals 1/2 mv squared. This formula helps us quantify the energy of motion. Ke stands for kinetic energy, m represents mass, and v is velocity. That's just a fancy word for speed. So both the mass and the speed of an object are crucial in determining its kinetic energy. So if you know how heavy something is and how fast it's going, you can calculate its kinetic energy. Cool, huh? This concept is not just theoretical, it has practical applications in engineering, sports, and even space exploration. Let's imagine two objects, a sleek sports car zooming down the highway, and a bicycle leisurely cruising in the park. Both are in motion, but they move at very different speeds and have different masses. Which one do you think has more kinetic energy? The answer might seem obvious. You guessed it, the sports car. But let's break down why that is. Why? Well, even though both are moving, the car is much heavier than the bicycle. The mass of an object plays a crucial role in determining its kinetic energy. Also, it's traveling at a much higher speed. Speed or velocity is the other key factor. Remember, both mass and velocity contribute to kinetic energy. The formula for kinetic energy is 1/2 mass times velocity squared. Think about a bowling ball and a tennis ball. The bowling ball is much heavier than the tennis ball. If you roll them both with the same amount of force, the heavier bowling ball will travel further. This is because it has more kinetic energy due to its greater mass. Why? Because it has more kinetic energy. The same principle applies to our car and bicycle. The car and the bike demonstrate how mass and velocity directly affect kinetic energy. The car, being heavier and faster, has significantly more kinetic energy than the bike. The faster and heavier an object is, the more energy it possesses in motion. This is why understanding kinetic energy is crucial in fields ranging from engineering to sports. Energy isn't just about movement, it's about the potential for movement too. This potential energy is stored and ready to be unleashed at any moment. Think about a roller coaster perched at the top of the highest hill. It's not moving yet, but it has a ton of potential energy due to its height. This energy is just waiting to be converted. As the roller coaster plunges down the hill, that potential energy transforms into kinetic energy, the energy of motion. The faster it goes, the more kinetic energy it gains. That's why you get that exhilarating rush as you zoom down the track. The transformation of energy is what makes the ride so thrilling. Let's look at another example. Energy transformations are not just limited to amusement parks. Imagine a car coming to a screeching halt. The kinetic energy of the moving car needs to go somewhere. The brakes generate heat, and the car eventually stops. This is another form of energy transformation. Where did all that kinetic energy go? It didn't just disappear. The answer is energy transformation. The kinetic energy is converted into heat energy. The kinetic energy of the moving car is converted into heat energy by the brakes and friction with the road. Cool, right? This heat energy is then dissipated into the environment. Energy is never lost, it just changes forms. From mechanical to thermal, electrical to chemical, energy is always on the move. From the roller coaster's thrilling descent to a car braking, energy transformations are happening all around us. Every moment, energy is being converted from one form to another, making our world dynamic and ever-changing. Now let's do a little thought experiment. Imagine you're driving a car at 20 miles per hour. Now imagine doubling your speed to 40 miles per hour. Do you think you have twice the kinetic energy? Nope. You actually have times the kinetic energy. Remember our formula, Ke equals 1/2 mv squared? When you double the velocity, you square it in the equation. This means that even small changes in speed can significantly impact kinetic energy. That's why it's so important to drive safely and obey speed limits. Doubling the speed doesn't just double the risk, it quadruples the energy involved in a potential collision. Pretty mind-blowing, right? Ready to see kinetic energy in action? Here's a fun and easy experiment you can try at home. All you need is a ramp, a few marbles of different sizes, and a few empty cans or blocks. Set up your ramp using a sturdy book or a piece of cardboard. Line up your empty cans at the bottom of the ramp like bowling pins. Roll a small marble down the ramp and observe how many cans it knocks over. Now roll a larger marble down the ramp at the same height. What happens? Does it knock over more cans? The larger, heavier marble should knock over more cans. This demonstrates that objects with more mass have more kinetic energy, even at the same speed. So, we've learned that kinetic energy is the energy of motion. We've seen how it's affected by mass and velocity. We've explored how potential energy transforms into kinetic energy, and we've even done a cool experiment to see it in action. Kinetic energy is a fundamental concept in physics, and it helps us understand a wide range of phenomena, from the motion of planets to the power of wind turbines. Think about it. The wind's kinetic energy spins the blades of a turbine, which then generates electricity. Kinetic energy is a powerful force in our world, but there's so much more to learn. Kinetic energy is also closely related to two other important concepts in physics: work and power. We've unlocked the mystery of kinetic energy, but the journey through the world of physics doesn't stop there. Next time, we'll explore how kinetic energy is linked to work and power. We'll discover how these forces work together to make things move and change. We will uncover the secrets behind how much work is needed to get things done, and how power influences the speed of that work. Get ready for more electrifying explorations in the world of physics. Stay curious, my friends.